Hi everyone. Today we're going to evaluate limits using limit laws. Let us see this example 1. Use the limit laws to evaluate the limit of this rational function 2x squared minus 3x plus 1 all over x cubed plus 4 as x approaches 2. For our solution, let us copy this problem down here. Then, let us show that we're going to take the limit of the numerator and the denominator respectively. So it will be like this. And in the numerator, we're going to show that we're going to take the limit of each of the term of this function. The same way, we will do it in our denominator. So we will have the limit of 2x squared as x approaches 2 minus the limit of 3x as x approaches 2 plus the limit of 1 as x approaches 2 all over. In our denominator, we take the limit of x cubed as x approaches 2 plus the limit of 4 as x approaches 2. Simplifying further, in our numerator, in the expression here, we can show that this constant 2 can be moved out, and we will take the product of 2 times the limit of the x squared. We will do the same for this expression. So we can show that 2 times the limit of x squared as x approaches 2 minus 3 times the limit of x as x approaches 2. Now, the limit of 1 as x approaches 2. This is the limit of a constant. The answer is a constant. While in the denominator, we will copy this expression down here plus let us evaluate the limit of 4 as x approaches 2. So we write that constant here. On the next step, we will now evaluate the limits respectively. Substitute the value 2 to the x in here, here, and also down here. So we have now 2 times 2 squared minus 3 times 2 plus 1 all over now 2 cubed plus 4. The numerator now becomes 8 minus 6 plus 1 all over the denominator 8 plus 4. Our numerator now is simplified into 3 all over the denominator 12. We can simplify our fraction here to be 1 over 4. This is our answer. We have another solution, and that is what we call direct substitution. We copy first our problem here, and then let us substitute the value of 2 to each of the x of this rational function. So it will be like this. 2 times 2 squared minus 3 times 2 plus 1 all over 2 cubed plus 4. It seems like this is a shortcut of the first method. From the problem, we jump directly to this step here. And this rational expression can be simplified into 3 over 12, or we say 1 over 4. This is our final answer. Example 2. Use direct substitution to evaluate the limit of the function 4x squared minus 1 as x approaches negative 2. For our solution, let us copy this problem down here. And then, let us substitute the value negative 2 to the x here. So we have 4 times the square of negative 2 minus 1. The square of negative 2 is positive 4. 4 times 4 is 16. And 16 minus 1 is equal to 15. This is our final answer. Example 3. Use direct substitution to evaluate the limit of this fraction, 1 all over 1 plus sine x, as x approaches 0. Let us substitute the value of 0 to the x in here. So we have now 1 all over 1 plus sine 0. We know that sine 0 is simply 0. 1 plus 0 is 1. 1 over 1 is equal to 1. This is our final answer. Example 4. Use direct substitution to evaluate the limit of this function, e raised to 2x minus x squared, as x approaches 2. For our solution, let us copy our problem down here. And then, let us substitute the number 2 to the x in the function. So we have now e raised to the quantity 2 times 2 minus 2 squared. This 2 times 2 is simply 4 minus the 2 squared is 4. And 4 minus 4 is 0. We can simplify the e raised to 0 as 1. This is our final answer. Example 5. Use direct substitution to evaluate the limit of the natural log, or ln of e raised to 3x, as x approaches 3. For our solution, let us copy this problem down here. Let us substitute the 3 to the x here. So we have ln of e raised to the quantity 3 times 3. And 3 times 3 is equal to 9. Please remember that the ln of e raised to x is simply the x. And that is for x to be greater than 0. Or we say x must be a positive value. It means we can simplify our expression here to be simply 9, or that exponent. This is our final answer. I hope you learned something from this video. See you again next time.